Good morning. It's a pleasure to me to give a lecture about our work in urban air pollution to such a great audience. We shall provide you a hands-on demo as well within the lecture. So the urban air pollution and other challenges of the urban air is well known for us. When we are walking in a city, sometimes we are surprised at why is it so smoky and why is it so dusty, why the other side of the road is not. And we want to explain that by computations, to be able to validate the situation with computational simulations, or vice versa. But anyhow, to make a digital replica of the urban air and the urban air pollution. So these three challenges are pretty well known for this audience present here. The first is the urban air pollution, which is above health limits in many cities. Some time ago, it happened also to Stuttgart that it was one of the best, not the best from the air pollution way indicator typically, especially, but now the situation is much better. And there are EU regulations about the air pollution level, how to handle them. But anyhow, we need good methods which, under high precision and high resolution of the city, we give good estimates of the air pollution. This is one challenge. How can we predict the air pollution under very high resolution for a city? The other challenge you can see here is the accidental toxic gas release in cities. Often happens that sometimes, fortunately only sometimes, but when it happens, then it is very dangerous for the inhabitants, and immediate response is needed. Within minutes, we have to react to this situation, to this hazardous situation. And for that, to be able to compute the spread of the toxic gases in a city, we need to know under high resolution the wind field in the city, the time-dependent wind field in the city. The third challenge, the third environmental challenge that I show you is the wind discomfort or even danger near tall buildings. Perhaps you don't have time to watch this video, but perhaps some of you already know this Flatiron building in New York City, when people, this is a good video, more than 100 years old video, when people are walking near the tall Flatiron building, and it was very windy. However, otherwise the city was pretty calm. So how can we predict from the urban planning point of view that building a tall building or other buildings, then this would destroy the comfort in the city. So this is our goal in the project, to develop digital solutions based on HPC for handling the urban air-related environmental challenges. So we want to develop solutions which are applicable also for architects, urban planners, and HPC codes needed for very high resolution simulations. Clearly, this is also a big challenge, how to provide HPC solution for non-HPC users. And we have to solve this challenge as well. Just to preview some of our results, that for the entire city to predict the wind field under real building geometry, compute, post-process the results to compute some KPIs, and also under very high resolution, within real time, of course, or faster than real time. So not in 1 year to compute that situation, but faster than real time to compute that. Also, this is our intention to develop codes, HPC codes, that support these solutions, which are reusable also for industry. So not only for tackling global challenges, but also solving global challenges. This is a video when we applied our tool, one of our tools, for an Audi pipe problem, and which was verified by measurements. So we have to compute the airflow in the city. That is, computational fluid dynamics solvers have to be developed, and actually we have been using 3 different solvers. The OpenFOAM, which is a very popular solver. Typically, it is running on CPUs. We have been developing on GPUs, the OpenFOAM as well. And it runs already on 1 GPU pretty well. The RedSync, which is a native MPI GPU code of ours, which runs more than 100 GPUs linearly scalable way on the Carbina. And the XIST, which is a Gosaramus code, the fork of it, and developed version of it, which has an automated load balancing feature. And we have made already a hero run on Lumi with that. High-performing visualization tool and the graphical user interface is also developed. This is a workflow. I don't want to go more details to the workflow, but instead let me introduce you one of our contributors to this project, from our young colleague, Aaron. And with Aaron, we shall show you a hands-on session on the UAP with the rest. We made in the Cascade 2 cooperation, we got in contact for long with ENCCS, the Swedish national node, the National Competence Center, and with the competition, they introduced us to Stockholm City. And from Stockholm City, we got data and concrete problems. And we want to demonstrate the UAP on those data. So this is our portal that you can see here, the Matso portal. And from this portal, we select from the applications. These are the applications. This is the HiDALGO2 portal, actually, the test portal. Is that the developer portal? It's the test version. The test version of the HiDALGO2 portal. And you can see here the wind comfort application. What's happening on the we can see only here. Oh, okay, sorry. Yes, please. Thank you. So this is the graphical user interface. Let me ask the urban users, planners, watch that you will run on HPC, but you have such an interface. That you have to select from a graphical user interface that scenario analysis is what we are presenting to you, and you select the concrete data files that you previously uploaded to a certain domain, similarly easily way, and you select that we are running now two scenarios from two opposite ends, and we select the space over accuracy, okay, create and run, and then to create and run, we have to select a domain of interest. This is Stockholm, and we select from the OpenStreetMap a domain. Now we select a small domain only, and okay, we create an instance, and we prepare an instance behind, so you don't have to take care of HPC preparation, but we do it. This portal does it, and we can run the instance, and the instance is running on Shoyo. This is our local cluster in our university, to be sure that we can deploy also to Ruby, Menuxina, and other EuroHPC machines as well. And here you can see the log files, and it's under progress. This is the running. First, we create the 3D geometry and create then the three-dimensional mesh for the domain, and it's ongoing. While ongoing, we can see the results of a previous simulation. If you click on another icon, you can get our CFDR visualization tool, the 3D results. And you can see that you can select between the time steps. Here, please select another time step into the middle. Aaron, please select another time step, yes. And also you can select the slices, which slice to cut the domain. And you can see here some slices. Okay, click on that, please. Yeah. And you can see it from another view. This is just some sample from the results. Maybe we can have a look back to the dashboard because we have only 2 minutes left. So maybe we can have a look at. Yeah, please click on that. We get some PNGs. This is the domain on which that we selected from the OpenStreetMap, and we have another PNG which the fixed buildings. We had to treat the buildings. Stockholm is especially very difficult city because there are very narrow roads, and we have to clean it, and double edges appear, and for 3D simulation we have to clean it, and we have another data set. Yeah, thank you, Aaron. In the break, we can have a look at the the results of this simulation. We don't have time. How much time we need? Can you see it, please? We need 2 minutes more for this domain. Please, thank you. And Carlos, can you help us, please, to reconnect the original computer, please? So we made a Castilla 2 success story thanks to Guntram, who is with us, who was one of the co-editors of the success story book. We published it also in this success story success story book. So our Center of Excellence appeared with this use case. This is our scenario analysis, the results of our scenario analysis, and this was the original what the Stockholm City unit could make. Much smaller domain, longer time, and while we can make it with HPC in a better way, and we can analyze that whether it is worth using HPC or not. And thank you for your attention.